Hello guys, I'm Alukosha Enoch and welcome to my tutorial section on binomial expansion. In today's tutorial guys, I'm going to teach you guys how to use the binomial theorem for expansion of a plus b raised power n for positive integral of n. Two, how to use the general term for a binomial expansion. The general term is actually applicable in to find the probability density function of binomial distribution. So let's get started with the question, guys. This is actually additional mathematics 0606. This is May June 2011. Paper 1 2. This is question 2. This is actually IGCSE past paper, and I want to believe this very session will also help you guys in your GCSE and your IB, your PSAT and AISL exams. Okay, let's get started with the first question, guys. I need to demarcate my board in order to manage my board well, guys. Okay, so now the first question: the coefficient of x raised power 3 in the expansion of 2 plus ax all raised power 5 is 10 times the coefficient of x squared in the expansion of 1 plus ax over 3 all raised power 4. Okay, find the value of a. So we have to find the constant value of a in this very question, guys. So how do we get started? Now guys, to complete this very question, the best thing is for us to use the general term for binomial expansion, which I also told you earlier that we use it in statistics. That is how to find the probability density function for binomial distribution. So I'm going to write the general term for you now. So let's just get started with that. Okay, so now the general term is giving us n. Guys, I want to believe you have very good knowledge of combination before now. If you don't, go ahead and watch my video on permutation and combination. But you can actually use your calculator to compute this very one. Okay, so n combination r, this is qr. This is just like don't let me go to statistics, guys. Let's just forget about that. So just you have to master this general term, then pr. So I wouldn't know in your textbook you can have something like maybe n combination r, maybe um, pn minus rar or something like that. So you can just use any letter that is applicable to you, but I'm good with this because this is like probability density function formula. Okay, so now this is the terms I'm going to use now. So let's see how to apply this now. Now let me just give you what we have in here. For example, this here is the number n, the total power number that we are the total outcome. Okay, and this is the possible outcome, power of 3. So I don't want to cover this stuff. Let me just put it on top here, power of 3 and power of 5. So n is 5 and r is 3. So now let's just go ahead and write that. So where n, for this very question, n equals to 5 and r equals, sorry about that, r equals 3 for this very question. Okay, then my q equals 2. Okay, so you'll be able to complete it easily, and my p equals, that is my coefficient of a square. Sorry, that's this one here, coefficient of x. So I don't know if I should tag it a. Actually it's meant to be like ax, but it's a because it's actually coefficient of x square, and the coefficient of x square, sorry, for coefficient of x square here and coefficient of x, that is 3 here. Okay, so that's what we have here. Okay, so for this one now, this is my q comes before p, this is my p, and for this one here, this will be my q, and this will be my p, a over 3. Okay, so if you don't mind, let's just make it easier for ourselves. Let me just use arrow to do that. Is the coefficient, you have to do away with the variable that is x, because we are dealing with coefficient here. So we're only comparing the coefficient, this coefficient. Okay, so the first one now, so this is my q and this is my p. Sorry about that. This is my q and this is my p, that is a there, and this is my q here, that is 1, and this is my p here, that is a over 3. something like that. So let's just work with this now. So let me get my calculator and see what we have here now. So n, that is 5, combination 3. Okay, because this one is expansion of this one. So I'm working with this one now. Okay, then the p there here is 2, right? So I have 2 raised to power n is 5 minus r is 3. So 5 minus 3 is 2, so that is raised to power 2. Okay, then I now have pr. So my p here, this is a, coefficient of x, that is a. So this like times, so you can use dot a raised to power r, and my r is 3. Okay, now the coefficient of x raised to power 3 in the expansion of this is 10 times, so equals to 10 times 10 into, then open a bracket now, the coefficient of x squared in the expansion of this. So for this one now, n is 4, and I have r to be okay, sorry about that, r is 2. Okay, so let me just do something, because I was trying to combine everything all together there. No problem about that. If you don't mind, let me just put this one in rectangular box so that you don't, at least this one is clear. Let me just write another value for p and q and put in blue for the 10 times. So let's do the 10 times here, where n and r is the same for both. No, different, it varies for the two questions. So n for the second one, for this one here, n is 4. Okay, and r is 2, because this one here in the expansion of this raised power 4 x squared, so r is 2. Then you have all the information already, so let's go ahead and do that. That's 4 combination 2, then open a bracket. So what is the p here? The q, the first one, 1. So 1 raised to the power of n minus r, that is 4 minus 2, that is 2, then times, then the coefficient of x squared is a over 3, a out of 3, so a out of 3. Okay, go back to the formula, all raised power r. So what is r here? 2, all raised power 2. Then you can close it. Then I can complete the task now. So I'm going to take my calculator and do, you can just go ahead and press shift, then you see combination. Combination is like division operator on your calculator. So that's what I'm going to do now. So shift, I'll just do 5, but you press your 5 first. Sorry about that. 5 combination. Guys, you guys are additional math students, huh? I don't know whether I should do it one by one. Let me just take it one by one, and so that you like. But next subsequent question, I'll be very fast about that. We need not to be writing everything. I could have plugged everything in my calculator just like that, but I don't want to do that because this is the very first question. So 5 combination, 3 is actually 10, and 2 square is 4. Sorry about that. I think I will just go ahead with that. This is 4a3, so that I don't need to waste much time, guys. 4a raised power 3. I don't know if my 3 is cool. Guys, my 3 is not cool. Okay, sorry about that. A raised power 3. Then close the brackets now. Equals to, I'll just go ahead with 4 combination 2. 4 combination 2, that is 6. So 6 times 10, that is 60. So this is 60. 4 combination 2 is 6, so 6 times 10 is 60. So 60 times 1, this one still remain. Then I can open the bracket for this one now. This is a square over 9. Guys, hope I'm communicating right. That is a square over 9. And don't forget that this is the coefficient of s square here, okay? And this is the coefficient of s power of 3 here, this one here. So I can cut this one here if you don't mind. I can leave it anyway. Let's see, 60 divided by 9. Okay, so I don't want to go that way. which is not a bad deal, guys. It's not a bad deal, but I don't know. Let's just continue. And this is actually 40. 40 a raised to the power of 3 equals to, guys, and let's just go ahead and do this. 3 here, 20. 3 here, 3. Okay, so I have 20 a square over 3. If you don't mind, guys, I can just go ahead and, you guys are advanced students, 20 here 1, 20 here 2. So I can go ahead and cross multiply now. So I have 6 a raised to the power of 3 equals to a square. Then I can divide both sides by a square. Then I'll end up with something like 6a equals to 1. Divide both sides by a square. Guys, you guys are advanced students. So a equals to 1 out of 6. And if we go back to the question asks us find the value of a. So guys, the value of a is 1 out of 6. So this is the end of the first question, guys. Hope it is clear. Let's go to the next question. Okay, guys, here is the second question. Let's take a look at the next question. Find the first four terms in the expansion of 2 plus x squared all raised to power 6 in ascending power of x. And the Roman figure 2 says find the term independent of x in the expansion of this. So I'll come back to this second question at the right time. So let's go ahead and take a look at the first question. Now, guys, to complete this very question, there are two ways we can either use Pascal triangle, which will take quite a longer time, and you can also use combination method. Okay, so I will go ahead with the combination method, guys. So let's start this one here. Let this be this is a and this b. So then if you have something like this, a generally a plus b, and you want to expand a plus b raised power n, where n is an positive integer. Okay, so and then the formula, the binomials um, expansion formula, or let's say combination, equals to, you have n combination r. Okay, better still, sorry about that. Let me just go ahead with the first step. So this is the first step. So the first term raised power n. Okay, or better see n combination 0, but n combination 0 will give you 1, so that's why I would like to start with this. Okay, then plus n combination 1. Then as the power of this one decreases, the power of this one will increase. So you have a raised power n minus 1, then b goes to 1. Because of my time, I will just end with this one, n combination 2. Okay, then a raised power n minus 2. Then the second term, which is b, we go to raised power 2, and so on and so forth. then 6 times 2 raised to power 5, because I would like to complete everything like that. 2 raised to power 5, and that is 192. So 6 times 2 raised to power 5 is 192. So this is sorry about that, 192. 192 x squared, then plus 6 combination 2. So let me use my calculator like that. 6 combination 2, then times, I'll plug in a calculator like that. 6 combination 2 times 2 raised to power 4. 2 raised to power 4, in order not to waste much time. That is 240. So that is 240. And don't forget that this is s squared. So s squared raised to power 2, that will be x raised to power 4. Then plus, I'll plug in calculator again. 6 combination 3 times 2 raised to power 3. So 6 combination 3 times 2 raised to power 3, raised to power 3, 6 combination 3. 6 combination 3. So 6 combination 3 times 2 raised to power 3, and that is 160. So 160. This is x squared raised to power 3, so that will be x6. Now that's all we are asked to find, guys. Because this question says that find the first 4 term in the expansion of this in ascending power of x. So this is what we have: 1, 2, 3, 4. So that's the solution to the first one. So let's go ahead with the second one. Roman figure 2. Okay, now find the term independent of x in the expansion of. So guys, don't forget terms independent of x. So that, like, we will be dealing with the coefficient only. Okay, so something like that. Okay, so now let's get started with the first one. I have this one here. This is plus, so no problem about that. Okay, so let's go ahead with this one here now. So sorry about that. So now the best thing for me is to, now this one is 2 plus this, and this is like this expansion here. Okay, and I have the solution to this already. This one here, I have the solution up here, so I'll just go ahead with this one here, then I will know what to do. So let's just go ahead and I'll work with this. Let me demarcate that so that you get to know that this is a new question entirely. So let's just demarcate this. So let's go ahead and expand this one here. 1 minus 3 over x squared. Okay, all square. I don't know, I need not to use binomial expansion for this one because this is just like quadratic. I don't want to say quadratic anyway. So but like this one now, you can just do one. I don't know, let me write everything, guys. So I can just do 1 minus 3 over x squared. Okay, I wouldn't well, I could have been smarter, but I just want you guys to see what I'm doing. Okay, so let's just do it like this. So this is pretty cool, guys, right? So now let me just get my final answer now, and you guys should be cool with that. So we have 1 minus, now this is twice of this, so 2 into multiple of this. Do you understand? Or let me just go ahead. Okay, minus 3 over x squared. Okay, I think you prefer it like that. Minus 3 over x squared, then plus 9 over x4. Okay, finally, I don't need to waste much time here now. So let me just write this because the time independent of x, I just need this. Let's just go ahead. Don't let me be too fast. So I have 1 minus 6 over x squared. Hope you understand what I'm doing, guys. Then plus 9 over x4. Then I want to multiply out with this. So the best thing for me, guys, is to show you something in square box. Let's just complete everything here. Now this is what I have here. So you can go with constant to constant. This is power of 2 to power of 2. This is power of 4 to the power of 4. So you end up with something like this. If you don't mind, let me just show you. Um, you can merge, because the expansion of this one here, let me just use this. You have something like this, 64. That's from the expansion of this one. The first four terms here for the expansion of this one is 64 plus 192 s square plus 240 x4 plus 160, which I don't need because I just want to end with x4. So let me just do something like this because of our time. So let me just put 3 dots. Okay, now if you compare this now, just take a line now, because we just want terms independent of x. Terms independent of x. So you can see 64 to 1. You can match this. That will be term independent of x because there is no x there. Then you can match this to this, because this will be like 192 x squared times minus 6 over x squared. So x squared will cancel x squared. So let me just strike it out so that you see that it's actually independent. So this x squared will cancel this x squared. So it's a term independent of x. And finally, this one here, multiply this, we also abstract this out, so that also becomes terms independent of x, because you have 240 x raised to power 4 times 9. This strike out. So what do we have now? So you have your final answer here now. So 64 times 1 is 64. Okay, then minus 192 times 6. 192 times 6, that is minus 1152. 1 1 minus 1 1, sorry about that, 5 2, then plus 240 times 9. 240 times 9, and that is 2160. 2160. So I'll use calculator to compute everything now. So 2160 minus 1152 plus 64 equals, so that is 1072. 1072. Guys, hope this is clear. So the term independent of x in the expansion of this is 1072. So this is the end of the second question. Let's look at the next question. And the coefficient of x squared in the expansion of 1 plus x over 5 all to the power of n, where n is a positive integer, is 3 over 5. So find the value of n. And then the second one says, using the value of n, find the time independent of s in the expansion of this. Okay, so let's get started with the first question. Guys, the coefficient of s squared. So let's go ahead and do this one, and we equate the coefficient of s squared to this value here. So if I have 1 plus x out of 5 all raised to the power of n. So guys, don't forget the general term. Let's go ahead with the binomial. Then you have n combination 0. Then this one we take the first power here. So and don't forget that 1 to the power of anything we still retain 1. So I'll just go ahead and do the needful, guys. I don't need to keep writing this for you guys. Okay, let's just go ahead and write. Okay, n combination 0, and that will be 1, so I don't need to start. Let's just go ahead. N combination 0, then 1 raised power n. This is my a, this is my b, you understand already. Okay, then plus n combination 1. Okay, 1 raised power n minus 1 we still give you 1. So I think I'll just continue with I will ignore this 1 because it is multiplicative identity. Do you understand? So I'll just keep increasing this term here. This term here is 0 here, so from here now it's going to be 1. So this will be x over 5 raised power 1. Hope that is clear. Plus n combination 2, then x raised power 5 all raised power 2. Okay, with this one here, I have coefficient of s square. So coefficient of s square will be 1 over 5 square, something like that. So I have that already. Hope that is clear. So now we are told that the coefficient of s square is equals to 3 over 5. Okay, so this is actually n. Okay, n combination 1. This n raised power 1, this is raised power 1, so this will be raised power 2, because you have here n minus 1. 1 raised power anything will be 1, so it's not going to affect. That's why I ignore this one. So plus we just continue indefinitely like that. So from here now we can go ahead. What is n combination 2? N combination 2 is n factorial. Guys, hope you know this already. From n minus r factorial, and my r is 2 here. So let me just go ahead and n minus 2 factorial, then 2 factorial. Guys, hope you are good with because this is actually binomial expansion. This is not permutation and combination. And if you need to recall anything on permutation and combination, guys, go ahead and watch my video on permutation and combination. So actually, if you want to do n combination 2, you have n factorial n minus 2. That is, if it will be n, let me just write something for you. N combination r. Let me just give you that advantage. It's giving us n factorial divided by n minus r factorial, then r factorial. Sorry about that. So that's what I have here now. So this is n combination 2. So and where r is 2. Okay, so times, that is this dot, times, and now this says that the coefficient of s square, so I don't need this x there, is the coefficient of s square. So that is 1 over 5 square. Guys, hope that is clear. 1 over 5. Because we ignore the x, is the coefficient I need. Sorry about that, huh? 1 over 5 all square. The coefficient of s squared there is 1 over 5. Yeah, the coefficient of s squared is 1 over 5. Then we are told that this equals to 3 out of 5. So I can complete it now. Okay, guys, to do this one here, I'm going to take. Okay, guys, let's go ahead and, sorry about that. Okay, guys, let's go ahead and work on this. Don't forget that we call n combination r is this. Okay, so let's just go ahead and do this now. So this will give me n into n minus 1 close the brackets, then n minus 2. Because I have n minus 2 factorial here, so I can end it here. You need not to continue n minus 3, n minus 4 like that. Then times 1 out of 25, because 5 square will give you 1 out of 25. Okay. Then this one divided by, this is n minus 2 factorial. Let me just write it here. N minus 2 factorial. Then times 2 factorial. So this n minus 2 factorial here, this one can go with this. Then don't forget that this equals to 3 out of 5. You guys are hard math students, so you understand what I'm doing. Now if you have what, this one is you can use this one now, because if you cross multiply, this will go with this. So this one can cut this. You don't want me to just be smart. So this can go with this 5, because if you cross multiply, this will multiply this and this will multiply this, so you can cut just to be this. I just want to be smarter. Then these two, we can multiply this one here too. Okay, so now what I have here now is I can open up this one here. So I have n squared minus n. Now 2 factorial is 2. 2 times 5 is 10. Okay, so 10, if you cross multiply, 10 times 3 will give you 30. So equals to 30. So you can bring it back now. That will be minus 30. Guys, don't mind me. Let me just write it for you. so that you know what is Aluko doing again. Okay, 2 times 5, guys, that's 10. Then when you cross multiply, that will be equal to 30. So at least everything is clear like this. So don't let me be too fast. Then you can now bring everything back now. So I have this trinomial equation, n squared minus n minus 30 equals to 0. So this is quadratic form of quadratic equation. So you can go ahead and factorize this. N. Then if I break this one down, this will be like 6 times 5 will give me 30. 6 times 5 will give me 30, but I want minus n. So this will give me now. So I have n minus 6. Guys, hope you know how to factorize. I don't want to say, oh, what is Haloko doing again? So this is clear already. You know how to factorize. So plus 5. You guys are admin student, right? Equals to 0. So now n equals to 6. Sorry about that. N equals to 6. I need to write it very properly. N equals to 6. That is when n minus 6 equals to 0. Or n equals to minus 5. That is when n plus 5 equals to 0. And guys, don't forget that we are actually looking for positive value of n. So for where n is a positive integer, so for n to be positive integer, then the only solution to this possible solution is n equals to 6. So that is the solution to the first question. So n equals to 6. Okay, now the next question says that I'm using this value of n, find the term independent of x in the expansion of this. Now guys, we have a value for n already. I don't know if I should complete the expansion here, or let me just create a rectangular box and complete question 2 here. And if I can't if that box is not rectangular box is not enough, then I will complete the remaining one here. Or if you don't mind, I can put it in blue box. Maybe you prefer that, so that you'll be able to differentiate the two questions. Okay, so let me just use rectangular blue. Sorry about that. Next question. Using this value of n, find the term independent of x in the expansion of 1 plus x over 5 all raised to the power of n into 2 minus 3 over x all raised to the power of 2. So guys, don't forget that we have the value of n here. So let's work on this left hand side first. So let me go ahead and expand this. So I have 1 plus x over 5 all raised to the power of 6, because n is 6, guys. So another thing I want you guys to notice this, if I were to expand this right hand side, and the highest power I'm going to have here will be power of 2. So I need not to complete this, so I'll just end with the term with x squared, then I'll stop. So let's get started now. So you assign this is your a, don't forget the way you used to do it. Okay, this is your a and this is b. Okay, and as this one is decreasing, the other one will be increasing. Okay, so this will be power of 6, power of 0, power of 6, power of power of 5, 1, then 4, 2, like that. Okay, so you are familiar with that already from the first two questions. So I have n combination 0, 1 raised to power 6, that will be 1, plus 6 combination 1, then 1 raised to power 5, then this will go to the power of 1, so that is x over 5. Then plus 6 combination 2, 1 raised to power 4, that is 1, then x over 5 raised to power of 2. So guys, I will need not to do 6 combination 3 and so on like that, because I only need the find the term independent of x. So by the time I want to multiply out, this is s squared, this will be s squared, so this will be the term independent of x. So let me just complete this one here now. I have 1 plus 6 combination 1 is 6. 6 times x over 5, so that is 6 over 5x. 6 over 5x plus 6 combination 2, 6 combination 2 is 15. So this will be 15. Sorry about that. Yeah, 15. Yes, 15. 6 combination 2 is 15. 5 square will be 25. X square plus, just use 3 dots here. Then I'm going to combine this with the expansion of this one here. Let me just go ahead and do the expansion of the other one here. So expansion of 2. So I have let me just demarcate it. Okay, so let's go ahead with this. I have 2 minus 3 over x all square. So that just do into 2 minus 3 over x. So this will give me 4, then minus 6 over x, then minus 6 over x, then plus 9 over x squared. So you can combine it now. In order not to waste much time, let me just combine it. Yeah, let's just go ahead. Okay, so I have 1 plus 6 over 5 x plus 15 over 25 x squared plus, now put your 3 dots. Now the term independent of x, so let me just write this one. So 4 under this, then minus 6 minus 6, that is minus 12, minus 12 over x, then plus 9 over x squared. So guys, I'm writing it on there so that you can see how we combine it now. So mean that this one here multiply by this one here, because that's what we want to do. We want to multiply this with this now. So the term independent of x, so this multiply this, so this will give me 4, then minus. Now this is x, this is x down, so the denominator we cancel this one now. So I'll end with 12 over 5 times 6 over 5 times 12. Sorry about that. 6 out of 5 times 12, so that is minus 72 over 5 minus 72 over 5. Guys, hope you understand what I did here. 6 over 5 x times minus 12x, so that will give you that. Then go ahead, 5 over 25 x squared times this one, x squared will cancel out. So I have let me just edit this. So I have 15 over 25 times 9. 15 over 25 times 9, so that's 27 over 5 plus 27 over 9. So this one is 15 over 25 times 9. So 15 over 25 times 9, that is 27 over 5. So let's plug everything in calculator now. So I have 4 minus 72 over 5 plus 27 over 5. So that is minus 5 is correct. Minus 5. Okay guys, but here we are told that we want a positive value here, so the answer for this n, the term independent of x is actually can I say n? Okay, not n, actually is the term independent of x, so the term independent of x is actually minus 5. Okay, Okay guys, here is my YouTube channel. Immediately after this session, I'll make the video on binomial expansion available via my YouTube channel, guys. So guys, there are quite good numbers of videos that will help you guys enhance your learning. Quite good numbers of video in mathematics, additional mathematics, ICT, robotic and coding that will actually help you guys enhance your learning. So for example, you can see something like transformation, two, the rotation, this IGCSE exam style question, solving polygon, creating artificial intelligence using scratch programming. You can develop AI using Python programming, develop your own games, something like Legend of the Fire Lord using Scratch or M-Block. This is vectors, GCSE. You can create a math quiz and graph of trig functions, simulating binomial distribution, permutation and combination. Quite good numbers of videos, ICT like database reports and data manipulation, website authoring, document production, mail match presentation, and many more, guys. Okay, if you find any of my video quite useful and helpful, guys, you can just go ahead and click like, and also subscribe to my channel for updates on new video. And here is my test shop also. Unlike my YouTube channel, there are quite good numbers of e-learning resources like boardworks, um, um, worksheets, okay, and all videos that you can have access to via my YouTube channel are also available on my test shop. Okay, so ICT, mathematics, additional mathematics, robotic and coding video. You can see something like statistics and probability parts 1 and 2, complete board work and video on how to solve polygons, matrices and determinants, and geometry and measure, application of calculus, creating artificial intelligence, and many more. Guys, if you find any of my e-learning resources also useful, go ahead and help review, and just go ahead and enjoy yourself, guys, and do have a great day ahead, and I wish you the best. Okay, so happy day ahead, guys. Bye.
Wake the streets up.